All right, so we have our class that we're going to use. We're going to need to add more functionality to this, but this is a good starting. It's a good starting point. You don't have to build out everything all at once when you're building a class. I'm only building what I can think of in the moment, and later I'm going to add more as more stuff comes up. But let's actually start putting stuff on our screen here. So we'll do our normal scene.set background color, and I don't know what my colors are anymore. So one is going to be like black, maybe two. Red. Which one was white? Color 13. I have two white, actually. Okay, color 3. Oh, that was close. I just needed to go one more. All right, so we'll just have the background white for now, just so I know that it's on. And now what I need to decide is how many rows and how many columns I'm going to have in total. And a normal small game of Minesweeper has 10 columns and 10 rows. So we'll say let rows equal 10, let cols equal 10. So this is going to keep track of how many columns and rows we're going to be building out here. And now I want to try placing out my grid here. Now this is where we're going to probably be adding some functionality to these nodes, but I'm going to create a function called placeGrid. And I'm also going to create a, I can do const for this. I don't know, so it seems like I use const usually for arrays when I'm using TypeScript, but it seems like MakeCode tends to use let, so I'll just use let. Doesn't really matter that much. Const just means it's not going to change, and you don't really change an array. You can add and remove elements, but it doesn't fundamentally change what the array is, so that's why you can use const for that. But let's use let. Let nodes equal. And now the nodes, the type for the nodes is going to be kind of interesting because it's going to be a nested array of nodes. So it's going to look like this, which is kind of crazy, but this is what it is. It's essentially we're going to have an array of nodes within another array. And that's because we're going to have a 2D array. And you've worked with 2D arrays before when you built out your brick breaker. You had to have a 2D array. Well, we didn't have to store it in an array, but essentially we have nested for loops to place them. And that's also how we store it in our array. So the way we build this out, we set up a for loop. So for let I equal 0, I is less than rows, I plus plus. And then for let j equals 0, j is less than cols, j plus plus. These have to be different, otherwise we're going to have some variable confusion there. So the outer for loop represents the rows, and the inner for loop represents the columns. So what we're going to do here is build a row. So we're going to say let row equal, and this row is going to be of type node, equal an empty array. And then at the end, we're going to build our row here by adding the nodes to that row. And then we're going to add that row to our nodes. So we'll say nodes dot push row. And the nodes is going to push the row. So that means we're going to create an empty row. We're going to add all of our columns to that row. And then we're going to add that row to our nodes. And this is going to allow us to have our nested array of nodes. All right, so let's start building out a node here. And this is the let node equal. It's going to be a new node. I believe this is how we do it here. And then column is going to be j. Row is going to be I, because our j is the number of columns, our row is the number here. And then eventually we're going to randomize this, but for now I'm just going to put false here. Do I even need the word new? Oh, I do. Okay. All right, cool. Every language does syntax of instantiating classes differently, so I'm glad I just remembered JavaScript or TypeScript. Anyway, we have our new node here that's built off of this. Now we need to figure out what image or what sprite is going to be used for this. So we need to create a function here that's going to return an asset or return an image for us. So get image function get image. It's going to be a public function. Do I need public on a function here? Maybe I don't. Function get image. And we need access to this, I believe. No, we don't. We don't even need the word function. We just need public. And it automatically has access to our this stuff. Like I said, every language has different syntax for this. Public means that it's accessible externally, which is what we want. Now, why do we need to have something to get the image? Well, we need to know what image we're going to be presenting. And that depends, right? So if, for example, if it's revealed and it has a bomb, then we need to show bomb. Yeah, so let's think about what we're going to be showing here. And we're going to have to actually add one more thing to check adjacent eventually. Right now we don't need that. I'm just going to try to get this rolling and then we'll figure out the rest as we go. This is this logic in get image is going to be quite tricky actually. So I want to return a specific image based on what's going on. So first of all, if revealed, that's not how you spell revealed, and if it's if this dot revealed, which means we're accessing this internal variable here. If this dot revealed, okay, so then we need to figure out what to do if it's revealed and if it's not revealed. So what are the possible things we can do here if it's revealed? If it's revealed, it's either we're gonna say if has bomb. Okay, we're gonna return assets.image, and it's gonna show the bomb image if this dot has bomb. Otherwise, we're gonna return the blank revealed, but we actually need to do some more stuff later. So there's a little note for myself, a to-do, calculate adjacent nodes for number. And why is this all weird? Oh, we need to return a value from everything. So we'll say return assets.image, and then it will be revealed. Okay, otherwise, this means that it's unrevealed. We're going to say if is flagged, this dot is flagged, return assets.image flagged. So that'll return that flag image. Otherwise, we're going to return assets.image unrevealed. Like that. Everything returns now, so it got rid of that error. Every path returns. Okay, great. So our nodes are here, and they're all added, and they're all pushed on. So this actually would be not place grid, but generate grid. Generating our grid. We're not actually ready to place it just yet. I'm going to create a separate function for placing our grid. But I just hit the 8.5 minute mark, so I don't think I have time to do that. Oh, I forgot to do one thing here. Row.push node. There we go. And I can verify that this works by, at the end of this, console.log nodes, just so I can kind of show what this looks like. And then we'll call it right at the beginning, generate grid, and then we'll open up our terminal, go over to output, change this to MakeCode, and we see a bunch of objects here. It's a little wonky, but it doesn't quite look right, but I'll have to check that in the next one.